Hello students, today I am going to explain you how to determine concentration of fluoride present in a sample of water by Spadon's colorimetric method. Apparatus required is spectrophotometer to be used at wavelength of 570 nanometer, providing a light path of 1 centimeter, and the reagents are standard fluoride solution 10 milligram per liter, Spadon solution and zirconium acid solution. Fluoride generally associated with few types of igneous and sedimentary rocks. It seldom occurs in surface water in appreciable quantity, but it occurs in groundwater in some specific geographical locations. Fluoride is toxic to human and other animals in high concentration, whereas small concentration is beneficial. A concentration of about 1 milligram per liter helps to prevent dental cavities in children. During the formation of permanent teeth, fluoride reacts chemically with tooth enamel, resulting in harder and stronger teeth. They are more resistant to decay. Excessive intake of fluoride can lead to discoloration of teeth. Permanent discoloration called mottling occurs when the fluoride concentration in a sample of water exceeds 2 milligram per liter, and if the fluoride concentration exceeds 5 milligram per liter, the problem of bone fluorosis can occur. Spadon's colorimetric method is based on the reaction between fluoride and zirconium dielectric. Fluoride reacts chemically with zirconium dielectric, dissociating a portion of it into colorless complex zirconium hexafluoride ZrF6-2. And if the fluoride concentration increases, color becomes progressively lighter. Now it is a spectrophotometric method. This method is valid in the concentration range 0 to 1.4. So we select a few standards in this range. One is blank is 0. There we have to take 50 ml distilled water. Then first standard is 0.4 milligram per liter. Then second standard is 0.8 milligram per liter. Third standard is 1.1 milligram per liter, and the fourth standard is 1.4 milligram per liter. How to prepare the standards from the standard fluoride solution? We will use the dilution technique. N1V1 equal to N2V2. N1V1 equal to N2V2. N1 is 10, V1 is unknown, N2 is 0.4 milligram per liter, and V2 is 50 ml. Then V1 is coming out to be 2 ml. If we take 2 ml of the standard fluoride solution and dilute it to 50 ml with distilled water, then we will be getting fluoride concentration of 0.4 milligram per liter. And for 0.8 milligram per liter, we need to take 4 ml of the sample and standard fluoride solution and dilute it to 50 ml with distilled water. And for third standard, that is 1 milligram per liter, we need to take 5 ml of the standard fluoride solution and we dilute it to 50 ml with distilled water. And for the fourth standard, 1.4, we need to take 7 ml of the standard fluoride solution and dilute it to 50 ml with distilled water. Then we will select the samples. Samples are river water, groundwater, synthetic sample, and take water. First I will show you how to prepare the standard. First is the blank. So I need to measure 50 ml of the distilled water in a volumetric flask. And transfer it to specimen tubes. Specimen tubes are already numbered. Then for the first standard, we need to take 2 ml. 2 ml of the standard fluoride solution. It is standard fluoride solution 1 ml equal to 10 microgram. That means it is 10 milligram per liter. 2 ml solution is to be mixed. Then remaining amount is filled by the distilled water. Then we mix it thoroughly and transfer it to one specimen tube which is numbered as 4. transfer it to the specimen tube. For the next standard, which is 0.8 milligram per liter, we need to take 4 ml. And rest is filled with distilled water to make it 50 ml volume and mix thoroughly with distilled water. Per liter. For 1 milligram per liter, we need to take 5 ml. For the next standard, we need to take 7 ml of the standard fluoride solution. Now I am going to measure 50 ml of all the samples. One is the river water. Before that, I have to rinse the measuring cylinder with distilled water. This is river water. Then again I have to rinse it. Then groundwater, 50 60 ml. Then next is synthetic shampoo. Next is tap water. Since no water is coming in the tap, I discard this tap water. Now I am going to add first balanced solution, and then I will be adding zirconium acid solution of 5 ml in all the specimen tubes. I have added now 5 ml of the balanced solution in all the specimen tubes. Then I will be adding 5 ml zirconium acid solution in all the specimen tubes. well as sample, because I have added 5 ml pattern and 5 ml terracotta acid solution in all the specimen strips. Now we will allow 10 minutes time for color development. Time we are allowing for color development.
Okay, sir.
Now 10 minutes time is over. This is the spectrophotometer. We have set the wavelength to be 570, and we will set the machine to 0 with the help of distilled water. So I am putting distilled water in a cuvette. This is providing a light path of 1 centimeter. It's 0 now. Now one by one I am going to measure the standards as well as the samples. For the first standard, this is the blank actually, 0, where the reagents are added. It is coming out to be 1.161. 1.161. The next standard is 0.4 milligram per liter. It is 1.093. 1.093. Then the third standard, 0.8 milligram per liter. .005. The next standard is 1 milligram per liter. Point 965. 0.966. And for the last standard, which is 1.4 milligram per liter, I am going to measure absorbance now. It's coming out to be 0.860. 0.860. Then it's the river water. I'm going to measure absorbance of river water. River water, it is coming out to be 1.136. Then groundwater. For groundwater, it is coming out to be 1.030. And the last sample, which is synthetic water, is coming out to be 0.984. 0.984. Now we have to plot a calibration curve. On the x-axis, it will be the known standards 0.4, 0.8, 1, 1.4. Then corresponding absorbance values are coming from higher side to lower side. Beer's law is followed in a inverse way. Then we fix the base fit line. Then we'll be using an equation y equal to mx plus c. M is the slope of this particular straight line and C is the intercept on the y-axis. Now for the unknown sample, using this calibration curve, for the first sample river water, the absorbance is coming 1.136. So we'll put in the y value 1.136 and x value and c value is defined by this straight line. How much? Suppose I am telling that y equal to 0.02x plus 0.05. This is an example I am setting. Then your y value, you put 1.136 in the y value, then you will get x, which is the concentration of the unknown sample. Similarly, you put 1.030 in this equation, then you will be getting concentration of fluoride in that particular sample. Similarly, you will put 0.984 in the y value, then we will be getting x value, what is the concentration of fluoride in that sample. Experiment is over.